Okay, next topic is 1.3, that is decimals and fractions, right? So when we just use calculator to simplify fractions, we have the decimal numbers. Okay, you need to know how to use the following types of the decimal numbers. Terminating decimals stop after a finite number of decimals. Terminating decimals are those numbers which are stop after some numbers of the decimal point. For example, 0.32 is an example of terminating decimal. Terminating decimals can also be written as exact fraction, right? Recurring decimals do not stop after finite number of decimal places, but they do settle into a pattern of digits that repeats definitely. For example, you can say that the terminating decimal is 0.623. This is also terminating decimal, and recurring decimal must be 0.111 up to so on. 0.232323. The specific pattern is repeating in this recurring decimals, or you can also say that in this example 0.316316316 up to so on is an example of recurring decimal. It would normally be written as 0.3 dot 1 dot 6 dot. It means that dot explains that how many terms are repeating in this decimal number. With a dot over the start and finish of the repeating pattern, recurring decimals can be written as exact forms. So here is the example: 0.4. Express the following as exact fractions. Give your answer as a fraction in the lowest form. So 0.4 can be written as, here 4 over, in the place of decimal we write 1, and how many terms on the right side of the decimal, that is 1. So it means that 1 0 placed on the right side of this 1, so it will becomes 4 over 10. So 4 over 10 can be simplified, 2 over 5. How? 2 2s are 4 and 2 5s are 10, right? Next one is 0.32 or 0.32. So we can write it as 32 over, on the place of decimal we write 1, and after decimal we have two digits, so we write it as two zeros. So 32 over 100. This can be written as 2 16s are 50, 32, 2 50s are 100. Again, 2 8s are 16, 2 25s are 50. So this is your simplest form. Next one is 0.875. So 0.875 can be written as 875 over, on the place of decimal we write 1, and how many digits after decimal? There are 3 digits, so we write 3 zeros on the right side. It will becomes, when we divide it by 5, 8 ones are 5 ones are 5, then 5 sevens are 35, again 5 fives are 25 over 5 2s are 10 and 2 zeros are as it is. So it will becomes 170 over 200. Again 5 3s are 15 and 5 5s are 25. This will becomes 5 40s are 200. Again 5 sevens are 35 and 5 8s are 40. So its simplified form is 7 over 8, right? Again, next example is we have to express 0.4 dot as an exact fraction. Dot means that this 4 is a recurring decimal, right? So we just let that x is equals to 0.4 dot, right? Then you can see that on the right side of the decimal we have a single digit that is repeating. So if the single digit is repeating, we multiply the both sides by 10. If two digits are repeating, we multiply the both sides by 100. If three digits are multiplying, three digits are repeating, it means that we have to multiply the both sides by 1000 and so on, right? So here one digit is repeating, it means that we multiply both sides by 10, it will becomes 10x is equals to 4.4 dot, right? And you can now subtract these two equations. This is your equation 1, this is your equation 2. We subtract equation 2 and equation 1, you get your answer, that is 10x is equals to 4.4 dot, and x is equals to 0.4 dot. When we subtract, here we have 9x and here we have just 4. So you can find the value of x by dividing both sides by 9, so it will becomes 4 over 9. So this 4 over 9 is basically the fraction form of this recurring decimal, right? So you can also check by using calculator, and also you may need to multiply both sides by 100 and 1000 if the pattern of repeating digit is of length 2 or 3, as we have discussed. Choose the right multiplier so that the digit move left by one full pattern. So here you can see that express 2.396 as an exact mixed number, give your answer in its lowest term. So you can see that here we have the repeating digits, there are 3. So first of all, let x is equals to this given number, then this multiply by the power of 10 larger enough to move all the digits along by one pattern, which is this case would be 1000. So here three digits are recurring, so it means that we multiply both sides by 1000. And you can also see that here is 2 point something, we just let x is equals to 0 point something, right? So 1000 x is equals to 396, right? So you point 396, here the dots are given and this dot is not given, okay? So you can have now this is your equation 1, this is your equation 2. When we subtract these two equations, we have 999, x is equals to 396, and your answer will be x is equals to 396. So over 99, when we simplify it, your answer will be 132 over 333. And also when we again simplify it, your answer will be 44 over 111. So this is the value of this x. But we have also the part 2, as we skipped in the question, so we write as 2 whole 44 over 111. This is your fraction form of this recurring decimal, okay? Next one is when you convert a fraction into a decimal, the answer will be either a terminating decimal or a recurring decimal. Write 1 over 8 as an exact decimal. So how we can write? We divide 1 by 8, so your answer will be 0.125. Again write 1 over 7 as a recurring decimal. So when we divide 1 divided by 7, you can see that 0.142857 dot dot. It means that after these 6 digits, its pattern will be repeated, okay? Now here is the next exercise, that is 1.3. Write these terminating decimals as exact fractions which give each answer in the lowest. So first of all, we have to convert these terminating decimals into fractions. In question number 2, we have to convert these recurring decimals into the fractions and have to convert in the lowest form. Also write these fractions into the decimal forms, which can be terminating or recurring. And also in question number 23 and 24, we can convert easy.